Welcome to your future. Welcome to Vision Academy. Let us unlock your full potential.
To solve a quadratic equation, we have to find the specific values for x that satisfy the equation. We call these values roots. The process involves breaking a complex polynomial down into two simple linear brackets. Finding these brackets relies on a technique called splitting the middle term. Success depends on how we manipulate the three numerical coefficients, a, b, and c. By following a specific sequence of operations, we can move from an unsolved equation to the final roots without relying on trial and error. Let's apply this to the equation 2x squared plus x minus 6 equals 0. The first step is to multiply the outside coefficients, a and c. Multiplying 2 by -6 gives us -12. Now we look for two numbers that satisfy two conditions at once. They must multiply to our product of -12, and they must add or subtract to equal our middle coefficient, b, which is +1. The pair 4 and -3 fits perfectly. Because 4 minus 3 equals 1, we can physically rewrite that middle x term as two separate pieces, +4x and -3x. We then group the terms and factor out the greatest common element from each pair. From the first pair, we pull out 2x, leaving x plus 2. From the second pair, we pull out a -3, which also leaves an x plus 2. Notice that we now have a common binomial, the x plus 2, shared by both halves of the equation. Because this bracket is identical in both terms, we can factor the entire bracket out. If these brackets didn't match, we wouldn't have a common factor to pull, indicating a mistake in the earlier steps. We pull out the x plus 2 and combine the remaining outside terms, the 2x and the -3, into their own bracket. Setting both factors to 0 gives us our roots, x equals -2 and x equals 3/2. This sequence, multiply, factor, split, and group, is the standard procedure for solving quadratics through factorization. Not every equation presents itself clearly. In this problem, 2x squared minus x plus 1/8 equals 0, the fractional term changes the visual pattern we're used to. Working with 1/8 as a coefficient makes the subsequent factoring steps much more difficult to calculate mentally. Pause the video and look at the equation. Try to find a way to eliminate that denominator so we can work with whole integers instead. By multiplying every term in the equation by 8, we clear the fraction entirely. The result is a more manageable expression. 16x squared minus 8x plus 1 equals 0. Now we return to the standard workflow. Multiplying 16 and 1 gives us 16. To get our middle coefficient of -8, we use factors -4 and -4. After splitting and grouping, we arrive at the brackets 4x minus 1 times 4x minus 1. When we solve for x, both factors yield the same result, x equals 1/4. This confirms that it's possible for a quadratic to have two identical roots. Clearing fractions allows us to treat a seemingly unique problem exactly like a standard one. Even though these two problems looked different at the start, they both followed the same progression. Once the fractions were cleared, the structural path to the roots became identical. To replicate this, use this 5-step checklist. First, clear any denominators. Second, multiply your a and c coefficients. Third, find the factor pair that sums to your b coefficient. Fourth, split that middle term and group your pairs. Finally, verify your brackets match and solve for x. This checklist provides a consistent method for handling quadratics. By following these steps, you can solve these equations through clear, logical progression rather than guessing at the factors.